Okay, Unit 8, Lesson 1, Investigation 1, Area Models. All right, we're going to start off by turning to page 522. All right, there's a part about Punnett squares and genetics. I know you're saying, genetics, we did that in biology class. Well, it helps for what we're going to do today. Genetics kind of helps set the tone for what we're going to do. And it also kind of shows you an example of area models. Michael, you have an assigned seat.
Yeah, but there, me if I try this.
All right. All right. Some physical characteristics such as freckles, such as freckles, eyelash length, and the ability to roll one's tongue are determined in a relative simple manner by genes inherited from one's parents. Each person has two genes that determine whether or not he or she will have freckles, one inherited from the father and one from the mother. If the child inherits a freckles gene from either parent or both parents, the child has freckles. That means freckles is dominant. Good. Freckles are dominant. Okay. If they inherit a non-freckles gene from both parents, they won't have freckles because non-freckles is recessive. Wonderful. A parent with two freckles genes must pass one freckles gene on and a non-freckles, and a parent with two non-freckles genes must pass a non-freckle gene on. If a parent has one of each, the probability is 1/2 that he or she will pass on the freckles gene, and the probability is 1/2 that he or she will pass on the no freckles gene. All right, kind of a recap of biology there for you. Now, first question: what's the probability a child will have freckles if both parents do not have freckles? So I set up this Punnett square right here for us. Little f, little f, little f, little f. Those are non-freckled parents, right? We'll get to that in a second, okay? Let's make the Punnett square first, because the Punnett square is going to help us figure out the probability. Each box on the Punnett square represents what? An offspring. Okay?
What?
An offspring, a child. Okay? And each combination of letters represents the freckles genes that they are getting. All right? So, for this one right here, what's this box? What's it going to be? Lowercase f, right? Or little f, little f.
They're all, yeah.
Okay. So since both parents have little f, all their kids will have little f, right? Now, if we remember, recessive is little f. That means no freckles. Okay. So, how many of these offspring have freckles?
None.
0 out of
4.
So the probability of freckles is going to be 0 out of 4, or 0, right? The probability of freckles, of no freckles is going to be what?
Wait, what? No freckles?
Yeah. Is this kid going to have freckles or no freckles?
No freckles, so it's 4 and 4.
No freckles. What about this kid?
No freckles.
What about this one?
No freckles.
What about that one? So all 4 have no freckles, right? So probability of no freckles is 4 out of 4, which is what chance? 1. Okay. Which means 100% of the kids will not have freckles.
If you say that so many times, it's using freckles.
That's
I
what
said freckles a couple times.
Darn freckles.
Okay. I want you to figure out the probability of freckles and no freckles if each parent has freckles, but the carrier of the no freckles gene. All right? So I want you to use this Punnett square to figure out the probability of two parents both carrying the freckles gene have a child with freckles and without freckles.
Oh, you spilled it. I still need to go.
I'm done.
Did I get it right? Disgusting.
Or do something like this.
I know, Punnett squares are in biology class. But we're doing Punnett squares because they're a good representation of
Branch, I'm
area
done.
models.
I think that's
Branch, I'm done.
Done?
Yeah.
Okay. So, this box right here, what's the offspring going to have?
Freckles.
Big F, right?
Yeah.
Yeah, what about this child?
Big F, little F. Freckles. Big F. Little F, little F.
Okay. Now the first question is no freckles. Which one's going to have no freckles?
3 out of.
One of them.
Wait,
One. That one
Yeah.
I'm right.
No freckles is little f, right? So this one right here is no freckles. Right? So how many out of 4?
One.
1. Okay. Which ones have freckles? Oh, I wrote that backwards. Okay. So how many have freckles? 3. This one has freckles. This one has freckles. That one has freckles, right? So how many out of 4? 3. So I know you're thinking, biology? Well, really, what we're looking at this for, guys, is using areas that are divided up into regions to figure out probabilities. Because if you look at the Punnett square, it's really one big square, right? Right?
Yes.
And there's 4 equal regions, right, Martha? Okay. And based on how many of those regions have little f in them, we can figure out what the probability the child will not have freckles are. Right? One region has little f. That means only 1 of the 4 will have no freckles. So using the area of the bigger square and how that compares to which ones have freckles and no freckles, we can come up with a probability. Right? And that's an example of an area model for probability. Right? An area model is a visual representation of probability. Okay? It's a visual representation of probability. And that's what we're going to be working on today. Figuring out how we can use an area model to figure out probabilities using or statements, and statements, and just kind of straightforward probabilities. All right? Are there any questions about the Punnett square one? Okay, that is probably the last Punnett square we'll work on. All right. So somebody, well, in this class, I said probably because there might be one like it later on. Okay. But the last Punnett square we'll work on, and some of you are thinking, oh yeah. But however, the Punnett squares, the ideas you use in Punnett squares are helpful for figuring out using the area model for probabilities. Right? So to get started, we're going to, continue. We're going to turn to page 524 in our books. And we're going to look at number 1.
You're supposed to tell us when to bring our book.
I know, I forgot. Hey, wants to bring your book today?
Yeah, that's
You should always bring your book.
Is this right?
Chris, you hear me?
Right book?
Well, I did, but instead of doing math, I made a quarter stand up on its side.
Nice job. Okay. Page 524, number 1.
It's a no change.
Okay. Page 524, number 1, it says, about half the U.S. adults are female. That's surprising. Not really. Okay. So, that's a little joke. I expect some of that. Alright. So, half the U.S. adults are female. So, I'm going to draw an area. Alright, here's an area. Now, how could I divide this up to show that half of the U.S. adults are female? What can I do? Okay, I can't divide a rectangle by 2.
Yeah, you can.
Okay. Oh, so draw a line down the middle. Okay. So then one side can represent male and one side can represent female, right? So this is an area model showing us that half of the total population is the rectangle. Half the total population is male, and half the total population is female. Okay. We're on the page that has the two boxes on front, not the one that has the questions. Okay. The one that has the boxes on it. There you go. All right. Now it says, according to a survey published in USA Today, 3 out of 5 adults sing in the shower. So this rectangle represents all the adults in the U.S. Half of them are male, half are female, right? Now, how could I take this and divide it up into more sections to show that 3 out of 5 adults sing in the shower?
6 out of 10.
I sit in the shower.
How can I divide this up, guys?
Line.
Okay, so how can I?
Already lines.
Okay, horizontal lines, right? We have a vertical line, which is for gender, right? If I put more vertical lines, that's like saying there's more options for gender than just male and female, okay? So I'm going to put horizontal lines for singing in the shower. Now, how many rows will I need?
4,
5.
5. Okay.
2.
So 1, 2, 3, 4, 5. Okay. Now, it says 3 out of 5 sing in the shower. If I use yes to denote sing in the shower and no to say they do not, how many yeses do I need? How many rows need to be labeled yes? 3. And then 2, 4, no. So, what this shows us, Michael, is that 3 of the 5 rows are yes, 2 are not. So that means 3 out of 5 people sing in the shower. 2 out of 5 do not. Okay, does that make sense? Okay. Looking at this area model, what's the probability if I pick somebody at random out of this population that I pick a female? So I grab someone else's population, what's the probability of female?
50%.
Okay, 50%, but how'd you get that?
2 options.
How many sections of this area are female?
5 out of 10.
1, 2, 3, 4, 5 out of 10. So the probability of picking a female is 5 out of 10, or 1/2, right? What's the probability of reaching this population and picking someone who does not sing in the shower? Was it Greg? 4 out of 10. How'd you get 4? Okay, count the no's and go over top the whole area, right? So there's 4 no's out of 10 squared. So 4 out of 10 reduces to 2/5. Okay, Dustin, you okay?
Yeah.
All right. Okay. Any questions about how I can count regions to make a probability? No? All right. Now, another thing we can use this for, besides just doing straightforward probabilities, we can use area models for and statements or statements. All right. So, what's the probability that I'm going to reach in the population and pick a female who sings in the shower? Okay, now I'm not saying take all the females and then pick one who sings in the shower, because that'll be 3 out of 5. I'm saying if I reach into the population of males and females and pick a female who sings in the shower, what's that probability? 3 out of 10, someone said?
Yes.
But how do I get that?
Because there's 3 females that.
There's 3 females that sing in the shower. Where'd you get that?
Right there.
Okay, on the table. So someone's might have a harder time seeing this. So what I'd like to do is I'm going to draw a square to represent female. I'm going to draw a triangle to represent yes. Okay? So I'm going to start by putting a square in all my boxes that say female. So those are all my female boxes, right? Right, guys? Let's read. Pay attention, please. All right. Now all my yes boxes. Okay, does that make sense? Yeah? Just do the squares and triangles make sense? Yeah? Okay. Now, if I want to find the boxes that have female and yes, that means I'm looking for the boxes that have a square and a triangle. Okay? Not square or triangle, but square and triangle. Right? So how many boxes have a square and a triangle in them? 3 out of 10. Does that make sense? Yeah. Christian, please stop in the corner. Okay. All right. Now I gave you a computer copy of this table rather than making you draw it yourself because you can do what to it? You can draw on it and then we can erase it. Okay. So I want you to erase what you had. Okay. Next one. Male and does not sing in the shower. So for male, I'm going to put a plus sign. For does not sing in the shower, I'm going to put an X. Okay? So for male, plus, 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 plus. Does not, X, 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 X. So if I'm looking for male and does not sing in the shower, I'm looking for the pluses and the X's. So how many pluses and X's are there? 2 out of
10.
What does 2 out of 10 reduce to? 1/5. Does that make sense? Does that make sense? Yeah. Okay. I'd like you to try these 4. Okay. Take a few minutes and try male and yes, female and no, male or no, female or yes. take a few moments and try those 4. Yes, reduce it again.
Can we do like 1.5 out of 5?
No. Do the 3 times. Three divided by 10. And you have math. Okay, guys, it sounds like we're done. Yeah? Shaquila, Marcel, heads up, please. Shaquila, Marcel. Thank you. Okay, so male and yes. What'd you get, Greg?
I write it down as this.
Jenlex, what was it?
3
Out of 10. Good. Okay. It's equivalent to female and yes, right? Okay. Female and no. 2 out of 10 or 1/5. Okay, equivalent to male and no. Okay. Now, male or no. Okay. For male, I'm going to put X. For no, I'm going to put O. Okay, males are there.
5.
No's are there. Right? Now, or statement means one or the other or both. So to figure out male or no, that means I'm counting all of my X's and all my O's, and I'm making sure I don't double count the ones with both. Right? So I'm going to go 1, 2, 3, 4, 5, 6, 7. So 7 out of 10. Does that make sense? Yeah. For female or yes? Okay, to save time, I'm gonna do I'll do a plus for female and I'll do a minus for yes. So plus, 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 minus, 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 minus. Okay. So now I'm gonna count all my ones with pluses, minuses, or both, right? So 1, 2, 3, 4, 5, 6, 7, 8 out of 10, like some of you said, and that reduces to what? 4/5. Does that make sense? Are there any questions? Any questions?
No.
Okay. All right. Now, does anyone remember what the probability of rolling doubles with a pair of dice is?
6.
Okay, there's 36 total options and there's 6 doubles, right? So 6 out of 36, like Greg said.
Good job, Greg.
So,
I said 1.
if I'm playing Monopoly, so here's our next situation, okay? And we're using an area model to figure this out. And we will be using, it's page 224, number 2 that we're going to be looking at, right? But our situation, right? We are in jail in Monopoly. Everybody been in jail before Monopoly?
No.
Not a fun place to be, right? Okay. Now, how can you get out of jail in Monopoly? Roll doubles or pay $50, right? Now, I'm in jail, I'm stingy, so I'm not going to pay my $50. I'm going to take my chances with rolling doubles. Okay? Let's say it takes me 2 tries to get doubles. Okay? If it takes me 2 tries to get doubles, that means What did I get in my first roll?
Not a double.
Not a double. What did I get in my second roll? A doubles. So what we're going to figure out is what's the probability it takes 2 rolls to get doubles. Okay? If it takes 2 rolls to get doubles, Christian, next time I hear that's mine. Okay? I'm just telling you. Okay? If it takes 2 rolls to get doubles, that means on the first roll, did I get doubles? No. But did I get it on the second roll? Okay. Don't forget that because the last couple hours we've been forgetting what it means to take two tries to get doubles. Okay? It means we get doubles. We don't get doubles on the first. Let me write it down for you. First, no doubles. Okay, DBLS means doubles.
Yeah.
And then second, doubles. Okay, that's what this means right here. Takes 2 rolls to get doubles. Means on the first roll, no doubles. On the second, we get doubles. And one more time, what's the probability of doubles?
1/6.
1/6. Okay, so we'll write it over here. Let's keep that in mind. 1/6. Right. So the probability of doubles, Greg, is 1/6. Right. All right. We're going to use an area model to figure this out. What's the probability to get no doubles in the first roll and doubles in the second? Okay. Now, down the left side, we have our first roll. Across the top, we have our second roll. Okay. Why are the rows labeled this way? Why is there 1 row with doubles and 5 rows with no doubles?
Because it's 1 out of 6 to your double.
Okay, so we have 6 total, right?
Yeah.
We have 6 total rows. The first row is doubles, 1 out of 6, right? The other 5 are not doubles, meaning the probability is 5 out of 6. Okay, so we have 1 row of doubles because it's 1 out of 6 get doubles, and 5 rows are not doubles because it's 5 out of 6 to not get doubles. Okay, nice job, Erica. All right. Any question about that? Okay. So which boxes represent no doubles in the first row or in the first row? Maybe I should ask which rows. Okay, remember rows are horizontal. Which rows represent no doubles in the first row? Okay. Rows 2 through 6, right? You guys see that? Okay, Marcel, Shaquille, are you paying attention or what? Okay, so rows 2 through 6 represent no doubles in the first row. So I'm going to put, we'll go with an X. Okay, so I'm putting an X in all of my boxes that represent no doubles on the first row. Starting to get some fish.
Fish.
No fishies.
I don't know what that means.
Okay, here we go. No, don't say any louder. Okay. Now, so my 6 rows, the one with doubles, shows me on 1/6 probability of getting doubles. Now for the second row, Travis, how many columns do I have?
What?
How many columns do I have for the second row? 6. How many columns represent doubles? 1, right? How many columns represent no doubles? 5. So we can label this doubles. Oh, I can't see anymore. No doubles, no doubles, no doubles, no doubles, no doubles. Does that make sense, guys?
Yep.
Yeah? Okay. Which column represents getting doubles on the first or on the second row? So which column is doubles on the second row? Is it the first column, second column, third column, fourth column, fifth column, or sixth
Second.
column? The second column is doubles on the
First one.
the first one, right?
Yeah.
This is doubles on the second row. So in all the spots where I have doubles in the second row, we'll put a circle. Okay? Okay. Now, which boxes represent the probability of it taking 2 rolls to get doubles? Which boxes represent the probability of taking 2 rolls to get doubles?
6 out of.
The whole first column?
No, the last 5.
Okay, the last 5, right? The 5 that have both marks in them, don't they? So these 5 right here
Nice job.
are doubles, or it takes 2 rolls to get doubles, right? So how many do I have here?
5.
5. Out of how many? 36. So the probability it takes 2 rolls to get doubles is 5 out of 36. Does that reduce? It can?
No.
No.
Yeah.
Well, you want to reduce it to 2.5 over 18?
Then
1.75 over 1.9.
Okay. Any further?
Yep.
Yeah.
Yeah. Divide 1.75 by 3, and it'll be something over 3.
Right.
I know.
All right. I like whole number.
I know.
Michael, I like whole number fractions.
I don't.
All right. Any questions about how we got 5 out of 36? All right. I would like you guys to try doubles on both rolls and not doubles on both rolls. Okay. So I want you to find the probability we get doubles on both rolls and the probability we do not get doubles.
Branch, just go to work right now.
Tonight's the only night where I don't have class or other obligations. So I think I'm going to stay home. Sorry.
Better take baby for a walk.
Break a vocal cord.
I will. I'll
Okay.
be able to talk tomorrow.
All right.
You'll probably be happier.
I was trying to say like break a leg like you tell people in theater.
Gotcha.
Did you try the problem?
I know the problem.
You know the problem?
Actually, I don't even know what we're doing. What problem we're doing.
We're figuring out the doubles on both rolls or not doubles on both rolls.
Okay, so doubles on both would be. Okay, I know. It's so easy.
How do you erase them? Guys, how do you erase your marks before you start the next one? Okay, erase your marks before you start the next one. Unless you think you can do it without using the table.
What? Wobbly, wobbly, wobbly. Why? It's not good. Wow, you did. I was trying to find the phone number.
Michael, Eric, you guys all done?
I know what the answers are. I already told you that.
Yeah, Eric, are you done?
I didn't do it
Why not?
because I didn't know what we were supposed to do.
We're gonna mess around with the labia.
Yeah.
You gotta find doubles on both rows. So you gotta figure out which row is for doubles on the first roll, and which column is for doubles on the second roll, and figure out where they overlap.
The same way you did over there, but on top.
Okay, try it. Use your area mount.
I don't want to glue my paper.
Okay. And you're not really practicing.
But I did it in my head. It's fine. No,
Sure
not,
it's fine.
not doubles on both.
Just that part.
Alright guys, sounds like we have enough time. So, which row is doubles on the first roll?
First one.
The first one, right? So this is doubles on the first roll. Right? Which column is doubles on the second roll?
The first one.
The first one. Listen. First row, right? Doubles. It's the only one that has doubles for the first row. That's 1 out of 6. Okay? Second row, the first column is the one that has doubles. Okay. That make sense? Okay. Now, doubles on both is an and statement, right? Means I got doubles first and second. So how many boxes have doubles first and second?
One.
One. One has both marks in it, doesn't it? Right? So our doubles on both is going to be 1 out of 36. Okay? Now, not doubles.
0.25 out of 9.
Okay, hold on a sec. Not doubles. Okay? For the first row, or for the first roll, rows 2 through 6 are not doubles, right? Right? Okay, so I'm going to put a dot in each of those. You guys see that?
Then do the ones
Okay.
that aren't.
And then rows or columns 2 through 6 are not doubles in the second.
Yep.
Now, which squares are not doubles on both? The ones with how many dots? The ones with 2. Okay? Because this column right here is doubles on the first row, or sorry, not doubles on the first row, but doubles on the second. Right? And this row right here is doubles on the first and not doubles on the second. Right? So the ones we're concerned with are the ones in there. Okay? And how many is that? You're on a different color. You can see better. Oh no. Screensaver.
Oh.
Okay.
You did that on purpose.
I did. So those are
That was cute though.
the not doubles, right? So how many boxes are there? How many?
25.
25. So our probability of not doubles on both is 25 out of 36, which Michael will conveniently tell us is 12.5 out of 18. Okay. But I like whole number fractions.
Actually, I was gonna say something else. Why can't
Alright.
we do the doubles on both? Why can't we do that as 0.25 over 9?
You could.
I know.
Are there any questions?
Should.